Okay, I want to talk about two more cases of partial fractions. If you haven't seen parts 1 and 2 of this video series, you probably need to go and watch them so you know what I'm talking about and the notation that I'm using. Cases 3 and 4 are to do with irreducible quadratic factors. Case 3 is when they're not repeated, and case 4 is when they're repeated. So you saw previously linear factors, repeated and non-repeated. Now we're going to see what happens with quadratic factors. I'm just going to illustrate these by example. I'm not going to write out general formulae. So case 3 example. I'm also not going to fully work this example. I'm just going to write it out, and you know the techniques to solve for the coefficients. So the example that I've got is this fraction here. Now, this example contains two irreducible quadratic factors. Now, this is a quadratic factor because it's got an x squared term in it. This is a quadratic factor because it has an x squared term in it as well. The point about it being irreducible is this is as far as you can factorize these terms without resorting to complex numbers. So that's what we mean by irreducible. Here's the factorization that you would use in this case. So that's just stock standard, that's normal happy linear factor. Here's our first irreducible quadratic factor. You introduce an x in the numerator. And for the other irreducible quadratic factor, we're up at D, you introduce another linear, you introduce a linear numerator essentially. So you end up with another constant. You're going to end up with 5 unknown constants, A, B, C, and D, and E, for a 3-term equation. And again, you solve it, you multiply through, you select useful values of x so that you can identify all of these A, B, and C. However, you might end up, in this case, you'll end up with a couple of simultaneous equations. And you've just got to solve them using what you learned in high school. So, an example of case 4, where you have a repeated irreducible quadratic factor. I've got, as my example, so they're nice linear factors. That's an irreducible quadratic factor. It doesn't just have to have an x squared term in it. It can also include an x term as well. So and I'll just move down here because this is going to be big. If you saw the video on repeated linear factors, you'll notice the analogy. So we firstly deal with our linear factors because they're nice. Now we deal with our first irreducible quadratic factor by putting a linear factor in the numerator. And now we've got to deal with our repeated irreducible quadratic factors. And I'm going to move on to the next line. I'm just going to continue my expression, right? Because I need plenty of room to write this out. Note that, like the linear factors that were repeated, you just keep repeating these up until you get all of your, you get the linear term, you get the squared one, and you get the cube. All right. So yeah, we're done. We've now got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 constants, and we solve this in the same way as we would normally.